are doing a little review here for our exponents and scientific notation quiz. So Unit 6 Quiz B. We're going to start with our review on exponents. So that's what the first page of the review is. I'm going to go over these and then we'll do the next page, which is scientific notation. So here, for the first problem, it says here, simplify your answers should contain only positive exponents. So we know the negative exponent rule, and we'll go over that here when we get to a problem that uses that. But I need to have all of my exponents be positive. So when I do whatever rule that the problem has asked me to do, if I end up getting a negative exponent, I need to switch that to a positive. So the first problem is our product rule. So I've got two numbers with the same base that are being multiplied together. I'm going to add those exponents. So this is going to be 6 to the really 12 plus 15th power. So 12 plus 15 is 27. So we've got 6 to the 27th power. And that is a positive exponent, so I am finished with that one. For number 2, I have the power to a power rule. When I have an exponent like this being raised to another exponent, I multiply those exponents. So 2 times 6 is 12. This is really 7 to the 2 times 6 power, which is 12. So it's just 7 to the 12th power. That one's also positive. So I'm done with that one. And that's it. Okay. For number 3, it's our quotient rule. Remember, our quotient rule says that we can just subtract the exponents when I'm dividing two numbers that have the same base. So when the bigger exponent is on the bottom, which it is in this case, so 75 is bigger than 25, I know it's going to be under 1. Okay, now since we've learned the negative exponent rule, we could just subtract these and get our negative answer and then put it under 1. So either way, it doesn't matter. I like to just subtract. I always subtract top from the bottom. If my answer happens to be negative, then I know to put it under 1. So I'm going to do 14 to the 25 minus 75 power. And then like I said, that is going to give me a negative amount. 25 minus 75 is negative 50. But we learned that negative exponent rule. It says if you have a negative exponent, you can make it positive by putting it under 1. So that's what I'm going to do, or put it on the other side of the fraction bar. So I'm going to put it under 1. And that's it. That's my answer. Number 4 is going over the zero exponent rule. Anytime you have a number raised to the power of 0, that's going to equal 1. No work to do there. It's just 1. For number 5, here's another chance to use that negative exponent rule. I've got 45 to the negative 5th power. To turn that positive, I simply have to move it to the other side of the fraction bar. I do want to point out, remember, moving it to the other side of the fraction bar doesn't change the base to a positive. If your base number happens to be negative, it's always going to be negative. Okay? It's only when we have a negative exponent that we can turn it positive. So that's it for that one, for number 5. For number 6, I got a couple things going on here, right? I have power to a power rule, and that's actually what I'm going to start with. I kind of like to follow the order of operations. If I see a number with parentheses, I want to do that first. So here, I'm going to just bring down the 3 for now. Okay, I'm also going to add a little 1 there. Because remember, if there's no exponent there, we know it's really a 1. And then that's going to be times 3 to the 6 times negative 2 power. Remember, power to a power rule says I multiply those powers. Well, 6 times negative 2 is negative 12. So now I have 3 to the 1st power times 3 to the negative 12th power. Product rule says when I'm multiplying two numbers together that have the same base, add their exponents. 1 plus negative 12 is negative 11, and then to make that exponent positive, I'm going to put it on the other side of the fraction bar. So it's just 1 over 3 to the 11th power. A lot of steps in that one. Same thing with number 7. I can see, there's a couple things going on. I can't use my quotient rule yet because I've got the denominator that's not simplified. I've got to simplify all of this before I can do my quotient rule. Okay. Well, the denominator is the product rule. It's multiplying two numbers together with the same base. So I'm going to add those exponents. This gives me 9 squared still on top. And then when I add those exponents, 3 plus 12 on the bottom, that gives me 15. Now I can subtract those exponents. Now I can apply the quotient rule, right? 9 to the power of 2 minus 15. Well, 2 minus 15 is negative 13. And I don't want a negative exponent in my answer, but I know to make it positive, I just put it on the other side of the fraction bar. And that's what I end up with. For number 8, a couple things going on here as well. A couple different ways you can go about this. So we could do the quotient rule first, do what's inside the parentheses, simplify that division, and then apply the power to a power rule. Or I could distribute this exponent to both the exponents inside the parentheses. Either way, we'll get the same answer. Okay, since I've already drawn the arrows, I'll just go ahead and distribute. I'm going to multiply the power to the power, but I have to do it to all the powers. I'm going to do it to the negative 6 and to the 2. Okay, so negative 6 times 3, that's going to give me negative 18. 2 times 3, that's going to give me 6. And now I can apply my quotient rule. My quotient rule says I can subtract those exponents when I'm dividing numbers with the same base. Negative 18 minus 6 is actually more negative, right? Negative 18 minus 6 gives me negative 24. Now to make that positive, I just have to put it on the other side of the fraction bar. So it's 1 over 12 to the 24th power. Okay. Now I want to show you real quick how we would have gotten the same answer doing it the other way. All right, if I erase my arrows, and I'll do this in red so you can see it's a completely different way. If I do what's inside the parentheses first, which is, just this quotient rule, okay, negative 6 minus 2, that's going to give me negative 8. So now I have 12 to the negative 8th power raised to the 3rd power. Now I can apply that power to a power rule. Negative 8 times 3, that gives me negative 24. And then to make that negative exponent positive, I'm going to do just what I did the other way. Put it under 1. Put it on the other side of the fraction bar. All right. Moving on to our scientific notation. So here on the next page, let's see, that was page 11. So now I'm on page 12 of your packet, but I've got the scientific notation review. So for each of these numbers to be written in scientific notation, that's what they're having us start with. Remember, scientific notation is basically made up of 2 parts. The first part has to be a number that is greater than or equal to 1, but less than 10. Okay, so I need to move the decimal so that I meet both of those criteria, and it's going to be times 10 raised to some power. Now that power tells us how big or how small the number is. It also tells us how many places that we're moving the decimal place. Okay, so it's gonna, if it's positive exponent, remember it tells us that the number is a larger number. If it's a negative exponent, it's telling us the number is smaller than 1. Okay, so here for number 1, I see I have a number smaller than 1, so I know my exponent right away is going to be a negative. I've got 0.0181. Where could I put the decimal so that this number is bigger, greater than or equal to 1, but still less than 10? It's going to be right here, right? It's going to be in between that 1 and that 8, because then that number turns into 1.81. So I've got 1.81 times 10 to the, and again, I said my exponent for sure is going to be negative because this number in standard form is smaller than 1. But negative what? Well, how many places did I move the decimal? Do my very technical term of swoops. 1, 2. It took me 2 swoops to get there, so I moved it 2 decimal places. My exponent is a 2. For number 2, let's erase all my stuff over here. For number 2, it's a number that's bigger than 1. All right, so I know my exponent's going to be positive, but it's 65,000. Where can I put the decimal so that it's greater than or equal to 1 but less than 10? And it's going to be right here in between the 6 and the 5, because then it's 6.5, which is greater than or equal to 1 and less than 10. It's greater than 1 and less than 10. So I'm going to put that 6.5 times 10 to the what? Well, how many places did I move the decimal? Let's do the swoops. I've got the decimal here initially on the standard form. 1, 2, 3, 4 places. So it's 6.5 times 10 to the 4th. For number 3, it's less than 1. I know right away. I'm just going to put that down that my exponent is going to be negative. But negative what? Well, where would I put this decimal so that I have a number greater than 1 but less than 10? It's going to go right here. In between the 5 and the 6. 5.68 is bigger than 1 but less than 10. How many swoops do I got to do? 1, 2, 3. I moved it 4 places. And then I almost forgot to put my 5.68 out there in front. And for number 4, another positive exponent. I've got a number that's greater than 1. Where am I going to put that decimal? Well, I'm going to put it right here in between the 7 and the 6. Let's not forget this time. Let's put it down first. So I've got 7.6 times 10 to the what? Well, how many places did I have to move that decimal? It was here. How many swoops? I got 1, 2, 3, 4, 5 of them. So we have 7.6 times 10 to the 5th power. Okay. Going the other way, to write each number in standard notation, I always start by writing the number that's in front of the times 10 by itself. So it's just 7 by itself. Okay, put the decimal where it belongs if it doesn't have a decimal on there already. So 7, where's the decimal on the number 7? It's at the end, it's behind it. And then this one says times 10 to the 5th. That tells me 5 swoops. I got to move that 5 decimal places. So I'm going to do that since it's a positive 5 to the right. So I'm going to go to the right 5 places. I've got 1, 2, 3, 4, 5. Put my new decimal there. And every swoop that doesn't have a number above it, I'm going to add in a little 0. Okay? Then I look and I see, okay, count over from the right 3 digits, put your comma. All right, so that equals 700,000. I like your answers to be written away from your work, right? This is the work right here. I don't want to try to read your numbers with all the swoops there and the decimal and where it was and where. Now, rewrite your answer so it looks all nice and neat, okay? Number 6, I have a negative exponent, so I know I'm moving my decimal to the left, all right? Write down everything in front of the times 10, off by itself, and then I'm doing 3 swoops to the left, right? My exponent's 3, so I've got 1, 2, 3. There's my new decimal. Every swoop that doesn't have a 0, that doesn't have a number above it, put a 0 in there. So I've got decimal and then 2 zeros, 1, 2, and then 6, 0, 8. That's my answer, right? Number 7, I'm only moving the decimal 1 place. So write out everything in front of the times 10 by itself. I've got 4.04. It's a negative, so I know I'm moving it to the left. Just 1 place. There's the new one. I don't have any swoops that don't have a number above them. So that's it. I'm done. It's just decimal 404. That's it. And then number 8, I don't have to move this one very far either. It's just 8.4. That's what's in front of the times 10. And then my exponent says I'm only moving it 2 places. It's positive, so I'm going to the right 2 places. 1, 2. only one swoop that doesn't have an exponent above, or that doesn't have a number above it. So I'm going to put a 0 there. And I don't even have to add in any commas for this one. It's just 840. All right, at the bottom here, we've got this word problem. Much like the word problems that we did in class for the lesson, we are trying to see how many times greater something is than something else. Okay, you see that phrase, how many times greater is something than something else, right? You know you're going to divide. So here it says the mass of the Earth is, I guess I could zoom in a little bit. Mass of the Earth is 5.972 times 10 to the 24th kilograms. That's huge. Remember we did that problem to the 24th power earlier this week. So we know that's a huge number. We can finally see why scientific notation actually does benefit us. This says the mass of the moon is 7.348 times 10 to the 22nd. Now remember when we compared our numbers in scientific notation right away, and we knew this, but this just backs up our claim that the higher exponent is always going to be the greater amount. And here we see, the Earth, of course, has more mass than the moon, and it has to the 24th power. It does have the higher exponent, right? So that's what I'm going to do. I'm going to set up my division the way the question is worded. It says how many times greater is the mass of the Earth? So that has to go first. 5.972 times 10 to the 24th divided by the mass of the moon. 7.348 times 10 to the 22nd. You would have thought I would have worked this out before doing this video, but I did not. So let's do it right now. Remember to use parentheses. So I'm doing open parenthesis, 5.972 times 10, caret button, 24, close parentheses, divided by, open parentheses, 7.348, I've said it right this time, times 10, caret button, 22, close parentheses, and I get 81.27386 times greater. So 81.2738616 times greater is the mass of the Earth than the mass of the moon. It doesn't seem like it would be that big. I mean, the exponent's, the exponent's only 2 bigger, right? 24 compared to 22. But it's 81.27386 times bigger, okay? So that's it for our review. If you still have questions, look through your packet. You might be able to find some help there. We've got the quiz right now, so good luck.